Now, we would like Mr. Vikas Manoria to be on the stage.
Good morning. Okay, colleagues and friends, good morning once again. And thank you for giving me this opportunity to speak in this forum. The topic that I have chosen is AI at Edge, Artificial Intelligence at Edge. Now, these are two of the hottest topics that is being spoken about in the industry right now. In fact, the three speakers earlier to me has also mentioned. So let me give you a little bit brief as to what exactly it is in industry from the industry perspective. Uh, my presentation is divided into four major parts. I'll take a few minutes to explain artificial intelligence, the concept of AI as far as the industry is concerned. I'll then take a few minutes to explain you something on edge computing, again a very hot topic nowadays in the industry. I'll then brief you exactly how both the technologies are getting married together, basically how AI algorithms or AI modules or AI apps can be deployed on an industrial edge or an edge management ecosystem. And lastly, I'll discuss a reference or basically a use case that we are doing with one of the customers in India, which encompasses almost everything that I'll be talking about during my presentation, basically AI, cloud, industrial edge, everything. So let us start with a small video. 2021, but I'm sure in the last 2 or 3 years, again, this has changed drastically. Some of the applications where AI is being used in industry right now is about product design, the quality inspection, and process optimization. But during the course of my presentation, I'll be also mentioning some of the examples that, or some of the applications or inquiries that are coming to us, which are far more beyond than what we are talking about over in this slide. The leaders in implementing AI in the manufacturing landscape is North America, Europe, Asia Pacific. Asia Pacific, primarily, again, in 2021, it was mainly China, Japan, those kind of countries. Unfortunately, the level of implementation in India was still less, but it has changed a lot in the last couple of years. And I'm sure that India will become one of the major players in the field of AI. Let us look at some of the major buzzwords because, AI, ML, these are some of the buzzwords which are being used very commonly. Let us have a brief as to what they mean, because a lot of us also use it interchangeably, and rightly so. AI is basically it is the broad term, it is the overarching system. A simple definition is a computer or a machine. It uses data to learn the underlying pattern and make predictions based on that data, right? They are literally mimicking human intelligence and trying to make a cognitive decisions out of whatever is presented to them. That is, overarchingly, that is what AI is all about. In AI, then we have various terminologies. One of the most common is the AI, ML, the machine learning part. Machine learning is a simply in a broad term, you can say it is the ability to learn without explicit programming. I'll also come back to this in the next slide as to how the programming part is different for AI and for a normal PLC program or a normal automation system. But ML is basically using those, wherein again the learning is done based on the data sets provided, based on the algorithm that are running behind the systems, for example, regressive analysis and decision trees, etc. Deeper down will be the DL as well as the neural networks. Neural networks is the core of the entire AI system. It is something like the neurons that run in our body. And based upon the depth of the nodes, we classify them as a simple neural network or a deep learning algorithm. For example, what I understand is if the depth exceeds 3 nodes, then it is being classified as a deep learning algorithm. Some of the deep learning algorithms which we know, which we are using also a lot of times is, for example, the object recognition systems, the voice recognition systems. Mr. Vivek also mentioned about the acoustic. So, somewhere the operators are able, not the operators, the machine is able to hear the acoustics and make a informed decision as to what is the next course correction. So these all fall under DL. Our famous chat GPT, the LLMs, they all fall under the umbrella of deep learning. How? Now, practically, I think from whatever I could gather, most of us, including myself, we are from the automation world. We are used to the PLC programming. So just one small slide as to how PLC programming or the normal trend of normal things that we have been used to, how it is changing as far as the AI world is concerned. This is how we normally do the PLC programming. We have an input. We have a function block, subroutine, or a programming block that we build based upon the logic that we have been given or the logic that we made. And based on that, there is an output, right? So basically, we know what is the output going to be. It is a rule-based programming. There are certain set of rules. It takes an input, processes it, gives you the output. So it's a rule-based coding. Machine learning is totally different. It is a paradigm shift from whatever we have been doing up till now. Herein we have an input, and then we have an AI model. There are algorithms, there are tools which keep on training this model to give a desired output. And based on the training that has happened, the AI system or the controller or whatever, wherever it is deployed, it will give you an output. So the rule is literally hidden in this case. Yeah, so it's a paradigm shift. Needless to say, the role of the data, the type of data, the quantity of data, the validity of data, the cleanliness of data that is being fed into the AI system, that becomes very, very important when we are going for an AI project. I would like to take a step back over here and also mention that this doesn't mean that the good old PLC is gone away, right? And this also doesn't mean that we have to forcibly put AI in everything. We still have majority of the applications, many of the applications that can be done by a good old PLCs. So somewhere when we are deciding upon an AI project, we should be very clear. This is a very important aspect that to decide as to which part of the plant, which part of the process, which part of the machine, wherein we want to go for an AI system. Something about based on the inquiries or based on the projects, what we are doing at Siemens globally. I'll show you one slide. Sorry, it's not clicking. Yeah. Some of the application fields which keep on coming where the AI is being used nowadays is visual quality inspection, anomaly detection, and then predictive maintenance. Again, I'll refer to Mr. Vivek's slide. He mentioned about the access control of people in the hazardous area. So we recently received an inquiry from a metal customer wherein they want to have an access control, or rather the AI system should be able to recognize whether a worker or whoever is in that area is wearing a hard hat or not. So these are the kind of new applications that keep on coming. So this is not an exhaustive list. This is only one glimpse of whatever we could gather. Industries is, of course, almost every industry is from electronics, water, machine building. Somehow they have not mentioned, or rather we have not mentioned metals over here, but metals also we are receiving a lot of queries. So it finds application everywhere. We have to be very clear and we have to judge it as to where we have to go for an AI or where we have to go for a normal system. Now, one question to you. My next slides will be something on industrial edge. How many of you are aware of, or how many of you are using edge computing? Okay, so good, thank you for responding. Okay, I must say that we are all of us in this room, everyone is using edge technology in some way or the other because our, the most widely used device, the mobile phone, is an edge device. So I'll go through what exactly is edge because that is something which is coming up in a big way in industry. On a very simple level, edge computing is a technology which is closing the gap between automation and clouds. Right now, okay, in the evolution of things in the industry space, the cloud computing came first, and then the edge computing came. So somehow we are all used to this, the data being sent to cloud and the analytics and everything being done on clouds through the high-level languages like Python and JavaScript and everything, or Java and C++ and all, making the apps in cloud, all the OEE apps in cloud and all that. Right? Industrial edge gives you the possibility of doing almost similar thing at your edge of the network, that is at your plant level or at your machine level. So not everything needs to go to cloud. It's not that cloud is gone forever. Cloud has its own very, very important usage. But a lot of things can be done directly at your plant level. Now, wherein we find, this is a slide which was around 3 or 4 years. When the slide came to us, when I first saw it, I thought it's only like a few words written over here. But over the last 3 years, we have realized that the kind of projects that we are working, almost each of these 3 limitations is there somewhere or the other with one of the customers. One of the important thing is the limitation of pure cloud technology would be the physical, the latency. You have to send the data to the cloud, the processing happens, and the data comes. So for some of the applications wherein time is very critical, this may or may not be required or desirable. Then a very important fact is legal. There are many, many customers across the realm who simply don't want to send the data outside their plant premises. Very simple. In fact, the first application of industrial edge we did in the subcontinent was for a customer who have their plants located in various parts of Africa. Okay, and they wanted to have a OE kind of an application, a performance evaluation applications from those plants, and they did not want to send anything on cloud. So for the applications, they use industrial edge because it was easier to develop it on the edge platform. And for the privacy, data privacy, or rather avoiding sending the data to the cloud, they use a VPN tunnel. So that is the kind of a requirement that keeps on coming, and this legal data ownership issue is something which keeps it's a very important thing for many of our customers. Then of course economic. We are working on 2 cases, rather we have already done the projects on 2 cases wherein the OEMs are from Europe. One of them is a very prominent mining instrument or mining project OEM. And they have their own cloud. They have their own applications on the cloud, the reportings and everything on cloud. But they don't want to send each and every data to the cloud. It becomes very costly for them. So they want to have an intermittent layer wherein they will process something and then the data goes to the cloud. And that is where, again, industrial edge comes very handy. So industrial edge leads to the additional functional enhancement of shop floor devices, all the analytics, pre-processing, decentralized intelligence, the uses of all the IT tools can be done through industrial edge. This is how the architecture looks like for industrial edge. We have the industrial edge device at the field level. It takes in data from PLCs or whatever controllers or wherever you want. It processes it. Then we have an edge management system on the plant level. This is an orchestration layer wherein the same you have a number of edge devices, you have a number of edge applications throughout your plant. This is the one layer which orchestrates it. And then you have choices of giving the data back to cloud. You can have an IEM server also in the cloud. So we have applications almost in all the realms. In fact, we were surprised. We were thinking that, okay, most of the applications will come in this thing, factory level and field level. But, okay, one of the customers actually wanted, a F&B customer, they wanted only industrial edge app to run on their HMI. They wanted the strength of the app, basically the reporting, kind of reporting which is not normally done in the SCADAs or the HMI applications. They wanted to develop that app and deploy it only on their 15-inch touch panel. So these kind of requirements keep on coming, and that is where, again, edge finds a lot of use. Now, why AI on edge? Edge, as I said, it gives you a lot of flexibility. It for the usage of all the high-level languages. In case of AI, how do we deploy a AI algorithm or an AI system or an AI model on your field level? What is the best way to deploy? We don't, for example, a normal PLCs or even a normal SCADA system that we offer nowadays, in fact, most of us, they won't support a AI algorithm per se. A AI algorithm or AI app which is developed in Python or something. So this is where edge comes into picture. It is very easy to deploy the AI algorithms on edge. And that is where this topic comes, AI at edge. And that is where, we feel that it has a huge, huge future. So, of course, latency requirements, then we have the IT-like software, data privacy, all these features, whatever I mentioned earlier, also applicable for AI, now can be implemented on edge through your, on your shop floor. This is how the basic AI on edge platform looks like. The data is collected from the machines and pre-processed at the industrial edge device through the southbound connectivity layers. Southbound connectivity layer. It is processed based upon whatever apps you have in the edge system. Through the northbound, it goes up to. Now, this can be a cloud. It can be a server-based PC. It can be anything which has a good compute power. Okay, the data is then prepared for training through various data preparation techniques. Once the data is ready, it will be used to train the model through various machine learning algorithms. The trained model can then again get deployed on your on-premise industrial edge management system, and from them to your various edge devices. Right now, this is a continuous cycle. For some of the customers who require a lot of retraining, this should be a continuous cycle wherein the data again goes to cloud or whatever server we are using for retraining. And this continues. And this is where the entire ecosystem works properly. I think many of you would have seen, if you have attended Siemens presentations, then this is a common slide that we show perfect integration of the OT world and the IT world. The IT world is represented over here by the data scientist. The OT world is represented over here by the automation engineers. It all starts with defining the AI business use case, and let us say anomaly detection, and then plan the project scope and data requirements. Then you collect the data, you label the data, and then you train the AI models and do the validation, and then you deploy it through an edge app on your edge devices. And then based upon the deployment, you again sense whatever the output is coming, inference, monitor, and whether you require the retraining or not, then you go for this layer. So it's a perfect integration of OT and the IT world. One more slide I wanted to show. This is mainly Siemens specific. There is a lot of applications and a lot of work being done on AI platform and AI edge platform in various forums. I'm sure every company is doing it. Some of the applications which have already released for AI, a snapshot of few of these applications. Some are in pilot phase, some are in the verge of releasing. And I would say maybe something around 10 times more are being developed across the world in various Siemens divisions, Siemens BUs. A lot of guys sitting over here, I can see colleagues from Advanta who are the masters in developing these apps. So a lot of these apps, very proudly, a lot of these apps are being developed in India also, right here in Bangalore. With this, my basic presentation on the AI and Edge is done. My time is also, I am on overtime now. Before I sign off, I want to take you through one case which we are working on without naming the customer. But this case very nicely depicts the strength of this entire concept that I have been talking about. Right? This is for a OEM based out of India, and they supply machines to end customers across the world. Right? And these machines they have a very high vibration, and they want to monitor. They want to make some new business cases also. They want to monitor the vibrations also. They want to monitor the various performance aspects of that machines, the production and everything, sitting centrally, as well as at the end customers level. And they also want to have a predictive maintenance for these machines. The system should be intelligent enough to analyze the vibration patterns and give you an output that, okay, this device requires a maintenance, or this is the time to change, something like that. So herein, we'll be supplying, of course, the entire automation system. We are also supplying the vibration system. From the machine level, everything goes to an edge device. From the edge device, it goes to our cloud MindSphere. A lot of data is going to get collected from a lot of machines in next 7 to 8 months across India. This will go to MindSphere. At the MindSphere, we are developing AI models to actually make the predictions. A new app is being developed for this customer based on these models, and these models are then going to deploy back to the customer's machines. So customer is also trying to get into new business models, wherein maybe they will take some kind of a contract with some of the customers, because there are customers who are ready to share a lot of data with this customer. There are end users who are ready to share a lot of data with this customer, so maybe they can monetize it, or maybe they can give a better service. So this is one such application that we are doing, a lot of advantages with the customers, and I think this is something which is going to grow a lot, because the level of inquiries and the level of movement that is there in the market for these kind of applications is simply too huge. And there is a lot of information also floating around. So somewhere, if we can all collate together and work towards achieving success in these applications, this is really going to turn around a lot of business cases, a lot of business problems that the customer is facing. So that is all from my side of presentation. Thank you. I've exceeded by 3 minutes. Sorry for that. Thank you.